Now that we've seen how to solve linear equations, we're going to look at how to solve linear inequalities. And they basically work the same way as we work through our steps, but the main difference between the equation and the inequality is that an equation will have an equal sign, saying that one side is equal to or is the same as another side, where an inequality will have symbols like greater than symbols or less than symbols, saying that one side of the inequality is bigger than another side, or maybe one side is less than another side. But the same 4 steps that we used when solving linear equations will still apply with inequalities. We still need to distribute so that we can remove parentheses and have our terms free to move around. We're still going to need to combine like terms to simplify each side. That's really just cleaning up each side of the inequality. We'll relocate terms by adding or subtracting, and that's really in an effort to move letters to the left and numbers to the right. And then we're going to isolate the variable or get it by itself by using division. So let's look at an example of how that might work. So here's an example of an inequality. 2x plus 7 is greater than or equal to 13. And so this statement is not saying that the left and the right side are the same as each other. It's saying that 2x plus 7 is either going to be equal to 13 or it's going to be greater than 13. We're going to go through the same process as normal. We're going to distribute, simplify, relocate, and isolate. For this problem, there's no distribution to do because I see no parentheses. And there's no simplifying to do because there are no like terms to combine. So my first step is I am going to relocate to make sure that letters go on the left and numbers go on the right. And right now, as it stands, my letters are already on the left. So my only job is to put my numbers on the right. And so this 7 that's on the left needs to move. Right now, the 7 is attached with addition, so I'm going to detach it with subtraction. And remember, as with equations, inequalities also, whatever you do to one side, you do to the other, because we need to maintain the balance. And if we subtract 7 from both sides, we now have a 2x on the left. I'll copy that greater than or equal to symbol, and then on the right side, 13 minus 7 will give us 6. So we have relocated all my letter terms or my variable terms are on the left. All my number terms or constant terms are on the right. And now we're going to isolate the x, which means get it totally by itself. Right now there's a 2 attached to it with multiplication, so I'm going to detach it with division. I will divide by 2, and in order to keep the balance, I will divide the other side by 2 as well. So that gives me an x on the left greater than or equal to 6 divided by 2, which is 3. And what this is saying, if we imagine kind of a number line situation here, I'm going to put 0 in the middle. 3 is a number that would be somewhere on the right side of 0. Oops. Oh, come on. And to say that x is greater than or equal to 3 is to say that I can equal 3. I can be at this value here, but then I need to be greater than that value. And things that are greater than or bigger than are going to be going towards the right. If I was talking about a less than symbol, I'd be going to the left. And one really easy way to remember how this works is there's kind of a neat coincidence here. When I have a greater than symbol, notice that it kind of looks like an arrow, and it's going to point in the same direction as my arrow on my graph. Another thing to keep in mind, if you have an equal to as part of your inequality, you will be able to equal this particular value. And what we'll end up doing is we'll end up writing what looks like a square bracket on that 3 to say that we can include anything from 3 on up to infinity. And there's a special kind of notation that we use called interval notation. So this would be considered our inequality. But interval notation is a way to describe infinitely many values from here to there, from the left to the right. And if I look at my picture, it would be from 3, including that number, all the way up to infinity. And I can't include infinity because it's not technically a number, so I use parentheses to say I can't equal that number. I use square brackets to say I can equal that number. And again, the reason we can equal 3 is because we saw that in our original inequality. We could be greater than or equal to 3. So let's look at another example and play around with it. Again, we're going through those same 4 steps as we had with equations. The first step is to distribute. We're trying to remove the parentheses so that those terms are free and loose to move around. And when we distribute, we'll have the 7x still there. 4 times 5 will give us 20. 4 times negative x will give us negative 4x. We still have that less than or equal to symbol, and then there's no distribution to do on the right side, so I'll just copy it. So now my parentheses are gone, and I need to simplify each side, and I can see in this case, I have a 7x and a negative 4x on the left. Those are like terms, so I can go ahead and combine those. 7x minus 4x gives me 3x. I still have the 20 on that left side. And on the right side, there are no like terms to combine, so I'll just copy it again. So we've gotten rid of parentheses, and now each side is cleaned up. And now what we want to do is we want to relocate. And when I relocate, I want to move letters to the left, and I want to move numbers to the right. Right now, I do have one letter on the left. I have the 3x term on the left, but my 5x term is on the right. So what I want to do is I want to detach it from the right side. Right now, that 5x is attached with subtraction, so I'm going to detach it with addition. And keep in mind, we need balance, so whatever I do on that right side, I now need to echo on the left side. So that will relocate the 5x to the left, and I want to do the same thing with numbers, but this time moving them to the right. So the 4 that's already on the right is great, but the 20 that's on the left needs to move. It's currently attached with addition, so I'm going to detach it with subtraction. Again, making sure to maintain the balance of this inequality by doing the same thing to the other side. And so now if I combine everything up, I've got 3x plus 5x on the left, which is 8x. And then my 20s cancel out. I also see on the right side my 5x's cancel out. And all that's left on that right side, 4 minus 20 gives me negative 16. So now my letters are on the left, my numbers on the right, and my last step is to isolate, which means get the letter by itself. So right now there's an 8 attached to the x with multiplication. We're going to detach it with division, and that's fine to do as long as you do the same thing to both sides. So now on the left, the x is by itself. This is less than or equal to negative 16 divided by 8, which is negative 2. And so in this one, we're saying that x can be less than or equal to negative 2. And if I want a picture of that to help me visualize it, negative 2 would be 2 to the left on my number line. Oh, come on. And it's saying that I can equal negative 2. So here's me equaling negative 2. And I can be anything equal or less than negative 2. And less than would take me somewhere to the left. Again, I'll just make sure that we can see this again. When you look at your inequality at the very end, notice that this part, this inequality part, looks kind of like an arrow, and the direction it's pointing is the same direction that it should point in your graph. And if you see an equal to as part of your inequality, that just means you'll be able to equal that number in your graph. And a lot of times, again, what we do is we use that to draw a square bracket. And again, if we want to look at that interval notation, we are looking at infinitely many values from here to there, from the left to the right. And based on this picture, the farthest left I go, the arrow is telling me to go all the way down to negative infinity. But I'll never equal negative infinity because it's not really a number. So I'm going to use parentheses to not equal infinity. But from there, I'm going to go all the way up to negative 2. And because I can equal negative 2, I'm going to use a square bracket. So where you have an arrow or an infinity, you have a parenthesis. Where you are able to equal something, you will have a square bracket. And so there's my interval notation. That should be a comma. It's kind of hard to see it. Negative infinity to negative 2. Let's try one more example. See if this helps us see the patterns. All right, again, same 4 steps as before. We want to distribute, simplify, relocate, and isolate. So for step 1, let's distribute to remove these parentheses. Again, the whole point of doing that is to loosen up or free up all the terms so that they can move around. So 15 times x gives me 15x. 15 plus 4 gives me 60. Or sorry, times 4 gives me 60. And then I have the plus 3. I still have greater than. 10 times x gives me 10x. 10 times 3 gives me 30. And I still have the minus 12. So there's our distribution step, trying to free up those terms by removing the parentheses. Now what we can do is we can see if there's any simplifying to do. So we're looking for like terms. And on the left side, I can see that there's a 60 and a 3. Those are both like terms. They're both constants. And same on the right. I see a 30 and a negative 12. Those again are constants. They are like terms. So let's go ahead and clean up these sides by combining those like terms. So 60 plus 3 will give me 63. And then on the right, 30 minus 12 will give me 18. So we have distributed to remove parentheses. We have cleaned up both sides. Now what we need to do is relocate. So let's relocate our letters to the left, relocate our numbers to the right. So the 15x is good where he's at, but the 10x needs to move to the other side. Right now that 10x is positive. What I'm going to do is detach it with subtraction. And it's fair to do that as long as I do it to both sides to maintain that balance. And I like the 18 where it is on the right, but I want to move the 63. Since it was added on, I'm going to detach it with subtraction. Again, that's fair to do as long as I do it both sides. And so now 15x minus 10x, that's going to give me 5x. The 63's cancel out, as do the 10x's. And now we have our greater than symbol, and then 18 minus 63 should give me a negative 45. And so now I see my letters on the left, my constant number on the right, and my last step is to isolate. So I want to get that x by itself. Right now, there's a 5 attached to it with multiplication, so I'm going to detach with division. And I will do that to both sides to maintain the balance. And so now I've got x on the left greater than negative 45 divided by 5 is a negative 9. And again, if I want to get a visual of what this is looking like, I've got 0 in the middle. Negative 9 is somewhere over here on the left. And this one's interesting. With this one, I don't have an equal to sign. So there's greater than or equal to, and then there's just a plain old greater than. And that's what I have here. I have a plain old greater than. I cannot equal negative 9, but I can be bigger than negative 9. So while I can't show negative 9 as an option, I can show everything bigger than it as an option. And again, want you to notice that how my inequality is pointing, it matches up with how my arrow is pointing. So they're both pointing to the right. And in this case, since I don't have that equal to as part of my inequality, I can't draw a bracket on the negative 9 because I can't equal it. So what I will use instead is a parenthesis to say I'm going to get really, 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 really close to negative 9, but I'm not going to equal negative 9. And so when I go to write my interval notation, again, this is just a special notation that writes infinitely many values from here to there, from the left to the right. Looking at my picture, I can see that I'm going on the left as far down as negative 9, but I can't equal negative 9 itself because I didn't see that in my inequality. It was strictly greater than. So I use a parenthesis to say don't actually equal 9, but from there, go all the way up to, in this case, infinity. And again, infinity cannot be achieved. It's not really a number, so I use parentheses. And so this is, again, just notation that says it's all the numbers that are included from negative 9 all the way up to positive infinity.